Today we're going to be looking at torque and calculating torque. To calculate the magnitude for torque is not too difficult to process, but torque as a concept and calculating a direction for torque can be a little trickier. We've got this vector operation that we haven't dealt with before called the cross product. The magnitude for the torque, and that's what these little absolute value looking lines mean, just the magnitude of a force, so no direction information, is just going to be the r vector, that's the position vector of the force, and that's compared to some point where an object pivots about. So maybe we have a door that has a hinge. We're looking down on this door, and maybe we've got a force F here, and then R would be a vector that goes from the hinge to that location where the door is, where the force is being applied. And so in this one we care about what this distance is, and we also care about the part of this force that's perpendicular to this position vector. So we could break that up into the part that's perpendicular and the part that's parallel to R. And this would be F perpendicular. So the other part of this, I can move that down here since you can move vectors wherever you want them to be. That'd be F parallel. And we can see, if you pull on this end of a door, you're not going to cause any rotation for the door, of course. So that's not going to be involved in our torque, our rotational force idea here. Now really, if we want to get into technicalities and the specifics of how torque is calculated, torque is a vector, and it's calculated by doing what's called the cross product of R and F. Now the magnitude we can get pretty easily there, just by doing a little bit of trig, figuring out what this distance is and what this part of the force is. We can calculate what our magnitude is, but our direction is going to be a little bit trickier, and we have to use something called the right-hand rule for this. So the right-hand rule, first off, get your right hand. Don't use your left hand. Your torque will be pointing the wrong direction here. Get your right hand positioned, and whatever you have to do to make this work, get your right hand positioned so that your index finger, your pointer finger, points in the direction of R. So point it to the right now. Okay, and now with your index finger still pointing in the direction of R, you need to make it so that your middle finger points in the direction of this applied force, F. So my index finger is pointing to the right, and I'm going to extend my middle finger a little bit, and I get kind of a V shape between my my two fingers that are extended there. So they're both pointing kind of to the right, but my middle finger is pointing upward a little bit on the page or on your screen. I have this position so that my thumb is up right now, and if I try and put my thumb down, I can kind of make that work too, but we want to make it so that our pointer finger is always extended straight out. So don't bend your pointer finger when you're doing this. Straight out, pointing to the in the direction of R. Now the only way to make this work is to have my my middle finger not extended all the way, so that first knuckle is bent just a little bit to get the right direction. So then my thumb gets extended all the way, so it's opposing the other two forces. So be sure to use your opposable thumbs for this. And so my thumb is going to be pointing out of the page. Thumb is out of the page. And so that means that my torque is also out of the page. The direction for my torque is out of the page. And we would show that with a little circle and a dot inside. I was always told that's supposed to look like an arrow from a bow coming at you, or if it were into the page, it'd be a circle with a cross inside.